All right. So if you want to enlarge or find the area of the circle, we take area equals pi r. Rate of change represents derivative. So if you derive that formula, it's dA dr, which is the derivative of area with respect to r. So you derive this with respect to r. So that's pi r squared being derived. So you get pi times 2 pi times 2r, which gets 2 pi r, which is the circumference.
See? You make fun of me for it.
No, I made fun of you for something completely different. Yes, I did. Because you said I did a 180, but it was actually supposed to be 360. Because 2 pi is 360. I would never make fun of you.
Michael's looking out for Lexi.
All right, evaluate the rate of change of A at r equals 5 and r equals 10. So what we do to represent rate of change at a point is you'd write dA dr, and then you'd put a little r equals 5. So what that means is it's the derivative of the area with respect to r at r equals 5, and then you plug it in. Yes. And then you do the same thing here. So you get dA dr at r equals 10. Okay. If we were to measure r in inches and A is measured in square inches, what unit would be appropriate for dA dr? So the idea is that if A is measured in square inches, area is inches squared, right? And inches for the next one, square inches of area divided by inches of a radius. So you have squared inches over inches, which would reduce to inches. And if you think about circumference, circumference is usually just inches, because circumference represents the wrapping around the length of a circle. So we are going to take that idea and extend it to motion. So we have motion along a line. So we're mostly focusing on position, then velocity, and then acceleration. So it says, suppose that an object is moving along a coordinate line. We call that line S, or an S-axis. So we know its position on the line would be represented as a function of time. So we say S equals F of t or S of t. So oftentimes when you talk about position, you have it as an S of t function. Displacement of an object over a time interval from t to t delta t would be represented by delta S, where it's F of t plus delta t minus F of t. And what you'll notice is that displacement looks an awful lot like the numerator of the quotient rule. Or not a quotient rule, the difference quotient, sorry. So delta S is the change in position at time 1 to time 2. Average velocity is represented by the change in distance over the change in time. Average velocity is our rate of change. or our slope of the secant, f of t plus delta t minus f of t all over delta t. Velocity tells me two things: how fast an object is moving and the direction of motion. So again, the direction means like is the object going up or down? That's going to come from being positive or negative. The instantaneous velocity is thus the derivative of position. The instantaneous velocity is the derivative of position. So v of t is ds dt or f prime t.
Would the following students please report to the office? Gianna Pelosi, Alexis Hawkins, Matt Rosans, JoJo Beaumarriage, and Blaze Zitz.
The speed is the absolute value of the velocity. Speed is the absolute value of velocity. Speed does not tell me direction. Speed does not tell me direction. Correct. The rate at which a particle's velocity changes is called acceleration. Acceleration measures how quickly a particle picks up or loses speed. Acceleration is the second derivative of position, or simply the derivative of velocity. So again, a big part of it is understanding terminology and appearance. A of t is the same as dv dt, which is the same as v prime t, which is the same as d2s dt squared, which is the same as s double prime t. Okay, for constant units in English, we have 32 feet per second squared, and in metric, we use 9.8 meters per second squared to represent the free fall constant on Earth. So, what we're going to do today is calculate some stuff. I think you have this one.
Yeah, it's basically.
Yeah, it's okay. I'll go backwards and do the next one. Oh wait, is this not your equation?
No, this is what we have. No, it's not.
See, that's what I said. I didn't like that one said.
We don't have any.
No, we have that one. It's just on the back.
Oh, like I put it in the printer wrong.
You put in an extra example. It looks like.
All right, well, let's just skip that page for now. Let's go to this. Maybe I meant to delete that example. A student walks around in front of a motion detector. Mr. Mannion actually has these. I was going to borrow them, and I forgot. So they're walking around in front of a motion detector that records their velocity at 1 second intervals for 36 seconds. The data is scored in the graphing calculator and used to generate the time velocity graph shown below, or to the right. Describe the motion as a function of time by reading the velocity graph. So again, this is a graph of velocity, so not position. If velocity is increasing, is the student moving forward, backwards, or standing still? So that's like what we want to talk about. Yeah. So if velocity is increasing, then the student is moving to the right or forward. So these represent time intervals. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. What do those tick marks represent in terms of seconds? The total motion is 36 seconds, and there are 9 tick marks. Every tick mark represents how many seconds? 4. So from 0 to 4, the student is moving forward.
Technically, if it's 0 to 12.
No.
But what's happening?
That just means the velocity is constant. He's still moving forwards. The only time he's not moving is when the velocity is 0.
Okay.
So that means the only thing is when velocity is increasing, that means that he's accelerating his speed. He's starting to move quicker. If it's constant at not 0, he's still moving forward.
Okay, so let's slowly explain that. I know, but I want to talk about why. So that makes sense to everybody. Why does a constant velocity not represent stoppage?
There's no acceleration.
Exactly. So velocity represents acceleration. It's pattern. So if the velocity is not increasing, it just means we are not accelerating. Think about when you drive on the highway in cruise control. Your speed that you are driving represents your velocity. If my cruise control is set to, 64 miles per hour,
95.
I'm not. No, I can't go over 80 or I lose my money from Allstate.
Manny was like, yeah, I was easily going 95 this weekend on 79 to go to a game.
So if you go 64 miles per hour at a constant velocity, you're not accelerating, but it doesn't mean you're not moving. So that's why if you look at the graph, this does not represent stoppage, it just represents a pace. So sometimes it's like moving forward, and slow it down. So that's why I kept saying, this graph does not represent position, it represents velocity. The zeros of velocity represent what?
Non-movement.
Or change in direction. So from 4, 8, 12, more like 14 seconds. At 14 seconds, the student changes direction and moves backwards. She continues to walk backwards. So 16, 20, 24, 26. And again, from here to here, it's flatlined. So if it's flatlined at 0, what's that mean?
She's not moving.
Means students standing still, right? Like they're not moving. Because they weren't going backwards or forwards, they were just stopped. It's like sitting at a stop sign. So if your velocity is 0, or at a red light, you're not moving, so you're stopped. Does that make sense? Are we okay with that? When is her speed a maximum? Yeah.
At -7, or just at 7, which would then be time would be 20.
Probably like 20. I agree. So again, remember that speed is the absolute value of velocity. So speed is kind of like saying that this graph was lifted up and then came back down over here. So whatever the maximum, whether it's above or below, since speed is absolute value of velocity, it is the highest peak of all. Well, this is definitely higher than that. Therefore, at t equals 20 seconds, her speed is at a maximum. Doesn't matter the direction for speed. I'm not sure next example. Thankfully.
Can we do it?
Yeah, we're gonna do it. Okay, so given 2t cubed, minus 3t squared minus 12t for t greater than or equal to 0. Why does t have to be greater than or equal to 0? Yeah, time does not exist in the negative realm. So it says find the velocity and find the acceleration. This is just like what we were doing last week. This is finding first derivative, second derivative. It's just a different way of saying it. So v of t is like s prime of t, or in this case, 2 times 3, which is 6t squared minus 6t minus 12. Acceleration is the derivative of velocity. So the acceleration is 6 times 2, which is 12t minus 6. If I ask you for units, if this is in meters originally, the derivative of that is meters over time, because derivatives represent ds dt, so ds would be the derivative of the units over the change in time, so meters per second. Then we do it again, where we derive, so it becomes meters per second squared, because it is the change in position over time again. Find the acceleration after 1 second. So to find the acceleration after 1 second, we simply find a of 1. Acceleration after 1 second is like instantaneous acceleration. So a of 1 would be 12 times 1 minus 6, which is 6 meters per second squared. To find the acceleration at the instant when velocity is 0, so again, when velocity is 0, we are changing direction. To find it when velocity is 0, we have to set this function equal to 0. So it'd be 0 equals 6t squared. Yep. Minus 6t minus 12. first thing I would do is divide out all of the 6's.
That's all.
And then I can see that it's factorable. Exactly. You have t squared minus t minus 2. So if you have a negative at the end, it means you have one negative and one positive factor. So you need something where the 2 is negative, and your middle term is negative. So my larger factor is negative. So it'll be minus 2 and plus 1. You can. It's not wrong. It's not. You always use quadratic. Okay, so since this is equal to 0, we find our roots.
Don't you include that 6 somewhere since you pulled it out?
Because it divided into 0.
Oh.
And there was no variable with it. If there was a variable, it would be different. It would be t equals 0. Okay, so we get positive 2 and negative 1. Well, we can't have a negative time. That was part of our rules at the beginning. So the only time interval at which the velocity is 0 is 2 seconds. So a of 2 So when the velocity is 0, so v of 2 equals 0 is what that means. So when the velocity is 0, the acceleration is 18 meters per second. Yes. Let's do another one.
What do you mean when it's velocity 2 or something 0?
At v of 2,
Yes.
velocity is 0.
You mean on the graph?
This probably has something to do with the graph.
Oh, yeah, you're right. So how do you know that?
Because I just solved for it. I literally set velocity equals 0 and that shit.
Okay.
So now I know that. Let me plug 2 in. Plug in 0. The position of a particle is given by the equation S of t equals t cubed minus 4t plus 3. Nope, t squared, sorry. Where t is measured in seconds and s is measured in meters. Find the displacement of the particle during the first 2 seconds. So displacement is change in position. So we want to find S of 2 minus S of 0. Displacement is change in position. So it says to find the displacement after 2 seconds. So we are finding the change in displacement or position after 2 seconds. So you need to know what is S of 2 and what is S of 0. So we get -1 for S of 2. S of 0 represents the starting position. So what that means is that the position of the particle at 0 was 30. So the displacement is -1 minus 3 or -4. So what does that mean if my displacement is -4? It means that the position of the particle after 2 seconds is 4 meters to the left. of the original position. Okay. Find the velocity for any time t. So when it asks you to find the velocity at time t, that is the general velocity formula. So you get v of t equals 2t minus 4 meters per second. We can use that to find the velocity at any time interval we want. So it says, what is the velocity after 3 seconds and what is the velocity after 4 seconds? So you would find v of 3 and v of 4. The acceleration is the derivative of velocity. In this case, since velocity is linear, the acceleration will be a constant. So what that means is that the acceleration of the particle in motion is always 2 meters per second squared. So even if I asked you to find a of 10 or a of 1, it will always be 2 meters per second squared. So a of 4, 2 meters per second squared. A of 7, 2 meters per second squared. When is the particle at rest? A particle is at rest when the velocity is 0. So again, we are solving for velocity equal to 0. Particles are at rest or not, or changing in direction when velocity is 0. So you have 0 equals 2t minus 4. So it'll be at rest at 2 seconds. So we now know what the velocity at 2, 3, and 4 is. When does the particle move to the left? When does the particle move to the right? So left and right have to do with the velocity. So when velocity is positive, the position of the particle is moving to the right. So when velocity is positive, the position of the particle is moving to the right. When velocity is negative, when velocity is negative, then it is moving to the left. So again, a positive velocity is to the right, a negative velocity is to the left. So if you think about velocity in terms of this problem on a number line, at 2 seconds, the velocity was 0. 0 isn't positive or negative, it's neither, so it's not left or right. It represents a change in direction. So when velocity equals 0, it's a change in possible direction. Doesn't have to be, it's just a possible. In order to determine if that change occurs, we need to look at the value of the velocity to the left and to the right. We know the velocity at 3 and 4 was positive. We already found it up above, right? So to the right of 2 is positive. The velocity less than 2 then, we need to find. We need to know what is v of 1. Well, -2. So the velocity to the left of 2 is negative. So it says, when does the particle move to the left and to the right? Well, it is moving to the left from 0 to 2. And to the right from 2 on. We don't really know when the particle stops. So if there is not an end time, then it's an infinity. Does that make sense for my non-physics kids? So let's graph it. So we'll do multiple colors. First, we'll start with position. So position is what is the particle doing when? So we know the position of the particle at 2 points already. We know the position of the particle at 2, and we know the position of the particle initially. The initial position is 3. So that means 1, 2, 3. And then we know at 2 seconds, it was -1. Found that in letter J. It's a quadratic. So that means that if this is up 4 and left 2, we can also go up 4 and right 2. It's also quadratic, so it goes up 4 and over 2, means it goes up 1 and right 1. So there's my position. Velocity is 2t minus 4. So it means it starts at -4 and goes up 2 over 1, up 2 over 1. When we calculated this, we got that v of 2 was equal to 0. Oh wow, v of 2 is 0. From 2 to 0, we said the position of the particle was left. This is negative. The negative velocity also correlates to a decreasing position. So the position function's decreasing, velocity is negative. Goes back to that table I gave you. Extrema, 0. Acceleration is the slope of velocity. Well, the velocity is constantly increasing by 2, so this particle is accelerating at a constant rate of 2. There's one more example on the back, and then I'll give you that one. Okay, it says find the times at which the acceleration is 0. So there's a whole bunch of space because in order to find when acceleration is 0, I need to know velocity and acceleration. So the acceleration is 0. 112t minus 18 is 0. Part B says find the displacement and the velocity at those times. So you have two choices if you don't, because this would be a non-calculator. So 27, you could either multiply everything by 4, or I said, okay, 54 is really close to 52, 52 cards in a deck, right? So 4 times 13 was 52. So I got my 13, and then I left me with 2 fourths left over. So now 27 minus 13 halves is really way easier than trying to get 27 to have a common denominator of 4, right? Yeah, that's multiply 27 times 4. Not that it's that bad. What? Yeah, I do 4 times 20, which is 80. 4 times 7. That's not 80. 27 times 4 is not 80.
What's the answer? Is the answer 13.5? Negative 13.5?
Negative.
I got 81.
You mean your fraction?
Mm-hmm.
No, okay. 27 times 4, though, is 100. And
Yeah, well, I don't know how I did it, but I got
no, well, you had to subtract like the 54 from that number. I don't know.
Oh, you're doing the position. Or you did velocity. I did position.
You're talking about displacement.
Yeah.
Okay. No, I did the velocity first.
You don't have to do this.
I have a bunch of paper.
Yeah.
All right, so the displacement means that we need to find S of 0, which is always easy. And then we need to find S at this value. Now, I look at the position function and I say, okay, I can take t squared away. And then that leaves 2t minus 9. Why I do that is because I really don't want to cube 3 halves. Where if I bring it out in front, I can kind of do some easier math here and just square 3 halves once. So S of 3 halves equals 3 halves squared times 2 times 3 halves minus 9. So I have 9 fourths, but 2 times 3 halves, what's nice is the 2's cancel, and I get 3 minus 9, so you get negative 6. And now it's just kind of easier multiplication than trying to have cubed it and get common denominators on this and that. So 6 and 4 both divide by 2, so you get 3. So negative 3 times 9 is negative 27, which is negative 15.
Should they be the same then?
It's just ironic.
Question.
What's our
What page on the slide before I go back up?
Question.
Yes.
The S of 0, how did you just get that?
You know it's 0 because there's a t in every constant, so it has to be 0.
S of 0 just came from plugging into S. So here's S.
Okay.
Plug 0 in
Why do you need the
to find displacement.
Oh.
Displacement represents change in initial to change in final. So that's initial. Yes. It's like 8 questions. Okay.